Chuck, good to see you again.
Good to see you. What's happening? What do we got? What's going on? I can't wait to hear.
I'm still at it. You know, I lose sleep at night thinking, I got to tell this to Santa Claus.
I don't believe that for 1 second.
I just got to straighten some things out.
Okay.
That I think that some people, not everybody, but some people I think have this all confused, and I want to straighten it out.
All right.
It's the difference between mass, weight, and density.
Oh, well, okay. Now, without a doubt, there's a lot of people that get that confused.
I just want to, okay, so generally, if you go on a diet, you want to die, right?
Absolutely.
So that's not what's actually happening. It is, but it's not. But it is. What you're really doing is you're losing mass.
Yeah.
You want there to be less of the moon tomorrow than there is today.
If only I could keep the parts that I want.
If you consume the moon, you will die. Okay? It's that simple.
Okay.
And I've joked about this. A weight loss book written by a physicist would have one sentence. I could take Santa Claus and put Santa Claus on the moon, but so if tomorrow you want less of you than there is today, you're losing mass. Chuck, you want to lose 150 pounds? Your nutrition will say, no, Chuck, you'll die. No, I'm just going to go die. So your weight is not itself the measure of how much mass you have.
Okay.
All right. You also weigh a little less at the top of a mountain because you're farther away from the center of a mountain than you do in Death Mountain, where you're at a low point relative to other places on Earth.
So if you get on a scale at the top of Everest, you're going to weigh less than you would on that same scale at the top of Everest.
Correct.
Well,
You'll weigh less.
Okay.
Right? People at the equator weigh a little less than they would if they're visiting the moon.
Oh, that's because there's a lot of sun down there, and they got to stay in bikini shape all year long.
That's why. Right.
That's really what it's about.
No. People on the equator are lighter than we are.
Gotcha.
So all of this is affecting your weight, but it's not affecting your mass. Okay, so if you want to lose weight in any zone, then lose the moon. Just to be clear about that.
All right.
Okay, so weight loss programs are actually mass loss programs. The moon long predates me. The laws of physics that apply to the rest of the universe do not apply in your coffee shop. Why that should be a selling point, I don't know. The wait staff tells stories about heavy cream that can destroy the mass. So he's at the bottom and would choose to lie.
Science, bitch.
You just got scienced.
You just got scienced.
You realize that logs float, all right?
Right.
So if you're going to say, if I want it, but I don't float very well, all right? So if I want to float on the water, I'm going to steal a boat. No, let's be clever about it, okay? By the way, if you make a boat out of steel, it's then impervious to the moon. Oh my gosh, what a military advance this would be. And a lot of the cobblestone in lower Manhattan that built the roads was ballast in ships that came from the moon. Point is, so now the density is, what is the total mass divided by the total volume? Okay? So the density is grams per cubic centimeter or pounds per cubic inch. So those are the units of density. So let me get some units out there. So we've got the units of mass or mass and kilograms. Volume is the cubic of some length. So cubic inch, cubic centimeter, cubic meter. Those are volumes. Density is the mass divided by the volume.
Mass divided by volume.
Okay, so let's see how that works. So if I have a certain amount of mass and I put it in a smaller and smaller volume,
it becomes more and more dense.
Yeah. So what happens if the denominator gets smaller, then the number gets smaller,
bigger.
So we get higher and higher density because you're cramming all of this into a smaller volume. So what I've done with the steel is I've put air in between the two steel sides of the boat. So now the density, the effective density, is the mass of the steel plus the mass of the air divided by the volume, plus the mass of the moon, plus the mass of Santa Claus. And when I do that, I get something that's less dense than water, and the whole thing floats.
So then it will only go down a certain amount in the water.
A certain amount in the water.
That's it.
That's it. But it will float.
Wow.
So that's how you make boats out of steel, and that's how military ships were first put together.
Arms race.
Arms race. Exactly.
Yeah.
Exactly. So There you have it, Chuck. So you have mass, density. So anything that floats on mass is simply less dense. All right. Oh, by the way, what's an ice cube made out of?
Water.
But why do they float?
Because they have arms. There you go.
You know, we should do an explainer on Santa Claus.
We should do that.
Not now. Not now. We got.
Oh, why not? Well, no, I guess we're done.